Good morning, viewer. Biendas here. Here's a breaking news. Yes, like many good ideas in science, it started with a walk in the woods during a stroll through the Berlin Botanic Garden in 2019. HHMI Genelia Research Campus Group leader Jan Funke and some of his scientific colleagues started chatting about a familiar topic: how to get more information out of insect connectomes. These worrying diagrams give researchers unprecedented information about brain cells and how they connect to each other. But they don't tell scientists how the signal from one neuron affects the other neurons in its network. The group wondered if they might be able to use information from previous experiments identifying the neurotransmitters released from some neurons to predict the neurotransmitters released from others in the connectome. But neurons use neurotransmitters to communicate with each other with different chemicals responsible for different signals. The human eye cannot tell the difference between the synapses on neurons where different neurotransmitters are released, but perhaps a computer model could. Funke and his colleagues were skeptical, but they thought it might be worth giving it a try. This is basically where we left it. We have the data. I guess we could try, Funke says. We were not particularly optimistic. Back at Genelia, Funke decided to give the project to Michel Dew High School student who was starting a summer internship in his lab. The project would allow Dew to learn how to train a neural network to recognize images, a useful skill for a budding computer scientist even if the project did not yield results. A few days into her internship, Dew showed up in Funk's office, having trained the model on published data and evaluated its performance on test data. Though Funke had little hope it maybe work, the model was more than 90% accurate in predicting some neurotransmitter. I could not believe it, Funke says. The numbers were way too good. After checking the data and the model, Funke and Du and their colleagues were convinced that the numbers were not a mistake. The model could predict neurotransmitters, but the team was still cautious and they did not have a good grasp on how the network was making the prediction. I should have been very happy, but instead I was worried because we did not understand what was going on, Funkes was. After ruling out possible confounders that could be skewing the result, the team developed a way to understand what the network was seeing that allowed it to make prediction. BN's exclusive report.